Expected return of a two-assets portfolio. The expected return of a two-assets portfolio is the weighted expected return from the assets in the portfolio. Portfolio risk or variance is calculated by using this formula. We need to find covariance between the assets before we can calculate the variance. Covariance is the measurement of the dependency between the return of two assets. It is computed by taking the difference between assets number 1's return and its expected return and multiply it with the difference between assets number 2's return and its expected return. Divide the results with the total dataset minus 1 if the dataset is a sample of a population. Covariance is in absolute term, which means it measures how much two assets change in tandem with one another. Correlation is a relative measurement of the dependency, which means it tells how strong two assets change in tandem with one another. Let's calculate the portfolio risk and return on a spreadsheet. Here we have the yearly closing prices of Amazon from July 2008 to 2018. As before, we calculate the geometric mean using these interest factors and arithmetic mean using the yearly returns. We find the variance and standard deviation. For how to calculate these values, you can check out the previous video. To find the covariance, we can start by setting up a covariance matrix. Covariance is computed by taking the difference between assets number 1's return and its expected return and multiply it with the difference between assets number 2's return and its expected return. Divide the results with the total number of sample, minus 1. Since our dataset is quite large, we will use spreadsheet formula to help us. We will use this return from Apple and Amazon and the expected return data. Covariance is defined as using the arithmetic mean, so we'll be using arithmetic mean as the expected return. We set up the covariance matrix. We will use mult function for this. Mult multiplies two sets of array. The first array in the formula must be in a row form, while the second array must be in a column form. Since our dataset is in a column form, we need to convert it to a row form to use as the first array. We will use transpose function for that. So we transpose these columns while subtracting out the expected return. Multiply it with the same matrix again, this time without using transpose, while subtracting the expected return. Divide with the total number of dataset, 10 minus 1. When you are working with matrix formula, you need to press Ctrl Shift Enter instead of Enter when confirming the formula. Ctrl Shift Enter. There. From the covariance matrix, you can see the covariance between Apple and Amazon as minus 0.0077. A stock's covariance between itself is the variance. You can confirm it here. Apple's variance is 0.096, the same as we calculated earlier. Let's calculate portfolio's return. We will start by having 30% in Apple and 70% in Amazon. For simplicity and consistency, we will use the arithmetic mean as the expected return. We multiply the weight with the expected return and sum up the result. This gives the return of 37% when you have 30% of your capital in Apple and 70% in Amazon. For variance, we will use this formula. We take the weight of Apple, rise by 2, multiply with variance of Apple, plus the weight of Amazon, rise by 2, multiply with the variance of Amazon, plus 2, multiply with the weight of Apple, multiply with the weight of Amazon, and multiply with the covariance between Apple and Amazon. This gives the variance of 0.049 and standard deviation of 22%. You can also use Excel formula to calculate these two results. For the portfolio return, we want to multiply these values with these values and sum up the result. You can use mmult function for that. The first array must be in row form. So these values. Second array must be in column form. Thus we will be using these two values. And as you can see, you get the same result. For variance, we basically want to multiply the variance and covariance matrix with each asset weight in the portfolio, and then we want to multiply it again with each asset's weight in the portfolio. So we can start by using mmult and mmult again, and the first array must be in a row form, but the weight is in a column form, so we will use transpose. We transpose to convert the dataset from column to a row. And second array is a column form. We can use this variance covariance matrix values, and then multiply that again with the weight of each asset in the portfolio. And since this is the array formula, you confirm the formula by pressing Ctrl Shift Enter, and as you can see, you get the same result. Minimum variance portfolio. This is a portfolio that has the optimal weight of assets which minimize the portfolio's variance. Based on the portfolio variance formula, we find the value of asset number 1 that gives the minimum variance. We do this by taking the derivative of the formula with respect of asset number 1 and set it equal to 0. We solve the equation for asset number 1. This gives the formula for the optimal weight of asset number 1 that gives minimum variance. Let's calculate this using Excel. We will use this formula. Apple will be our asset number 1. We start by taking the variance of asset number 2, in this case Amazon, minus covariance between Apple and Amazon, divided by variance of Apple plus variance of Amazon, minus 2 multiplied by the covariance between Apple and Amazon. This gives about 48% in Apple and about 52% in Amazon. And this gives 36% return and 21% standard deviation. You can also use the spreadsheet solver function to calculate the minimum variance portfolio. To do that, we can start by adding a row here for summing up the assets width. Click on Solver. It's under the Data tab. After you have installed it, it's here. On how to install Solver, check one of the introduction videos of this course. Let's first turn the allocation back to 30/70. Now we will use Solver to find the minimum variance portfolio. Solver, set objective, variance as minimum by changing these two variables. Then we set a constraint, add, where this cell must be equal to 100%. That means 1. OK. Solve. There. Okay. As you can see, you get the same result as what we calculated manually earlier. Let's add more companies in the portfolio. Here we have Google, Microsoft, and Berkshire. We calculate the returns, the variance, and the standard deviations, the same way we did on Apple and Amazon. Check the previous video on how to calculate these values. To be able to calculate the portfolio's variance, we need the covariances between these assets. Covariance is computed by taking the spread from the expected return of an asset and multiply it with the spread of another asset. We will expand our variance and covariance matrix here. Again, we will be using the MMULT and transpose formulas. We select the area our result to be shown in. We transpose these yearly returns columns to convert them from columns to rows, minus the expected returns to find a spread. Multiply multiply with the same columns minus the expected return divided by the number of sample, in this case 10, and minus 1 because it's a sample of a bigger population, so it will be 9, and Control Shift Enter because this is a array formula. Now we calculate the variance. Our portfolio variance formula is for 2 assets. For more than 2 assets, we need to calculate every combination of covariance and variance between each stock and sum up the results. This is quite tedious, so we will use spreadsheets formula to help us. But first we set up random ways of investment in each stock. In this case, 1/5 of the total investment in each stock. There, 20% investment in each stock. We will be multiplying this with the variance covariance matrix adjusted for the weight of each stock. So a multi twice and transpose the weight multiply it with the variance covariance matrix and multiply with the weight of each stock. Control Shift Enter. This gives the variance of 0.01 and standard deviation of 11%. We still haven't calculated the portfolio's return. As mentioned earlier, you can use Excel formula to simplify the calculation. So a multi, the first array will be this row, second array will be this column. Enter. This gives portfolio return of 24%. Now let's find the minimum variance portfolio. We will use solver function for this. So data, solver, and we minimize this cell, the variance, by changing these values and keeping the total weight to 100%. So it's 1. Okay. Solve. This gives these allocations: Apple 10%, Amazon 12%, 26% in Google, 19% in Microsoft, 33% in Berkshire, and this gives a portfolio return of 20%, variance of 0.01, and standard deviation of 10. If you don't want to have more than 25% of your total capital invested in one stock, you can set constraints in Solver. You do this by going to Data, Solver, add this range of cells less or equal to 25%. Okay, solve. Okay, this gives 25% of your total capital invested in Google, Microsoft, and Berkshire, while 11% in Apple and 14% in Amazon. And this gives return of 21% per year and variance of 0.011 and standard deviation of 11%. In this video, we learned about how to construct a variance-covariance matrix, how to calculate portfolio's return and variance, and how to calculate a minimum variance portfolio. In the next video, we will include the option to also allocate a proportion of the total capital into bank deposit, and also include investment in other kind of asset, in this case in a bond fund.